So the first law of conservation of mass, we are going to begin. So let's talk about centuries back. What was the common observation long time ago regarding chemical changes? Like you can see on the screen, these are the chemical changes. A plant is growing from seeds, right? These are the chemical changes. These are also chemical changes. We have become adult from infant. Okay? So these are all the chemical changes. Candle is changing. So what did you notice here? What are you noticing here? About the quantity of matter. What are you noticing? Think. Yes. In some of the examples, matter is producing, matter is growing, matter is increasing, like in the germination of plant, like in the other one, from infant to the adult, matter is coming. And what is there in the candle's example? Matter is destroying. Okay, there is no more candle there. So what was the concept long time ago? That matter could be destroyed or matter could be formed, matter could be prepared. Okay, that was the old belief. Then there was this French chemist. His name is Lavoisier. He disproved this concept. What was the concept before him? That matter can be destroyed, matter can be developed, matter can be produced. Okay? So he disproved. And how did he prove it? He proved it, according to him, if you perform an experiment, if you carry a chemical reaction, if you proceed a chemical reaction in a closed system means nothing can enter, nothing can leave. Then there isn't any change in matter. There is no change in its mass, net change. The matter, the quantity remains same. Okay, that is why you can see on the screen, when a reaction is carried out in a closed system, the total weight of the reactants. What are reactants? Things before the reaction, they are called reactants. Things after the reaction is completed, they are called products. Reactants on left side and product on right side, like this. Reactants changes into product. Like carbon plus oxygen gives carbon dioxide. So these are the reactants, the products. So according what was observed by Mr. Lavoisier, that if a reaction is carried out in a closed system, nothing is escaping out, nothing is entering in. For example, if you take a piece of coal, carbon, and in a closed system, might be a closed jar having some quantity of oxygen already in it. If you burn that, if you take that piece of carbon and having oxygen inside, just weigh that jar or that arrangement. Might be, suppose it's 151 gram. Then you started heating it. The coal will convert into carbon dioxide. We are assuming something here, only carbon dioxide will form, okay? Now, after the completion of this, you notice now that what is the weight of this product? Again, it must be 151. So that was the thing which was observed by Mr. Lavoisier, that the mass of the reactant must be equal to the mass of the product. Okay, before him, the scene was different. The thought was different. What he did, it was just an example. What he did actually, Lavoisier performed an experiment in a closed system, as you can see on the screen. Just replace these reactants with the reactants of Mr. Lavoisier. Okay, so he took red oxide of mercury. What do you mean by red oxide of mercury? HgO. HgO. This is called mercury oxide. This is called red oxide of mercury. And when you heat it, it will convert into Hg and O2. Okay? Wait. So HgO, red mercury oxide, when he heated, Lavoisier heated it in a closed jar, in a closed vessel, in a closed container, what happened? It decomposes into mercury and oxygen. Before starting the experiment, he measured its mass. He found its weight. He noted down its weight. After the reaction, he noted down the weight of these two objects again. He didn't let oxygen to escape. And he found both the weights are 100% same. So the concept of the destruction of matter has been changed. Right? You can see on the screen this equation also. Mercury oxide is decomposing into mercury and oxygen. Okay? Now, what he concluded, I just told you. When he determined the mass of the liquid mercury means this mercury. This is in liquid form. There are only two liquids in the periodic table. One is the mercury. The other one, bromine. Out of 118 elements, there are only two liquid elements. Okay? One is mercury, the other one is bromine. So, when he noted down the weight of mercury, liquid mercury and oxygen, what he found the same. That is why you can see on the screen, their combined masses were exactly the same as the mass of the red powder of mercury he had started with. And for the first time, this oxygen was discovered in such a way. So, in this way, Lavoisier was able to discover a gas that is called later on as oxygen. So that is why it's written there on the next paragraph, you can on the screen. Lavoisier also established that the gas produced by heating mercury oxide means this oxide, red oxide, which we call oxygen, was the composition of air. He told that this oxygen is present in oxygen. So here comes the law. What is the law? What was Mr. Lavoisier's statement regarding all of these experiments? So, the old concept of producing or destroying matter has been abolished, has been disproved. And what is the new law here that we call law of conservation of mass or law of conservation of matter? That matter can neither be created nor be destroyed. We can't create matter, we can't destroy matter in any chemical reaction. The only thing that we can do, that we can transform matter from one form to another form.